Today, the line between lab tech and world-changing tech has become razor-thin. Humanoid robots are being trained before they even exist physically. A US chip giant is putting Chinese humanoids inside the most demanding environment in modern industry. And in the middle of all this, the job market looks stuck, while AI attracts trillions and grows as if nothing could stop it. What is happening isn't just technological evolution, it's a gear swap across the whole system. Let's break it down. Before we continue, subscribe to the channel and turn on notifications so you stay on top of everything happening in the world of technology. Now, let's get into the video. Robots learning before they are born, the simulation that unlocks physical AI. Training autonomous robots is still expensive and slow for one simple reason. Collecting real-world data costs time, money, and yields low volume. But there's an even more irritating problem. What works perfectly in simulation often fails when it's transferred to a real robot. This gap between virtual and physical slows innovation in sectors that depend on robotics, like manufacturing, healthcare, logistics, and agriculture. To get around this, Lightwell built a simulation platform on top of NVIDIA's ecosystem, with tools such as Omniverse and robotics-focused frameworks like Isaac and Isaac Lab. The idea is to turn simulation into an experience factory. You create scenarios, repeat conditions, change variables, increase variety, and scale training data to a level the real world can't deliver. Here's the decisive point. Human operators enter this simulated world using virtual reality headsets, spatial controllers, and even exoskeleton systems. They teleoperate simulated humanoid robots to perform complex industrial tasks such as transport, precise positioning, and coordination in heavy operations. The data coming out of this teleoperation isn't limited to what was captured. The platform applies techniques that amplify the value of this material by up to 10,000 times, creating more robust and diverse datasets. With that, NVIDIA's foundation model for robotics, GR00T, is fine-tuned using synthetic data that combines images, joint states, task descriptions, and scene metadata. Before this turns into a reliable skill, the pipeline goes through two-stage quality assurance, automated validation, and manual review to ensure physical realism and consistent behavior. And the most important part, this is already beyond talk. Lightwell deployed these models on Unitree H, one humanoid robots inside a Geely automotive factory. They perform transport tasks, component positioning, and coordinated handling of heavy loads, maintaining stability even in dynamic environments with people around. Development cycles fell from months to weeks, and the platform reached a 100-to-1 ratio of simulated to real data. In other words, simulation stopped being an experimental crutch. Maybe the big revolution isn't robots learning faster, but robots learning before they even exist physically. And when you can train robots at this pace and at this volume, the question changes. You stop asking if humanoids will enter industry and start asking where they will enter first. And one of the most unlikely and most demanding places just opened the door: the semiconductor industry. Texas Instruments using Chinese humanoids. Walker S2 enters the industry's most demanding environment. Texas Instruments, one of the largest semiconductor companies in the world, has started deploying Chinese industrial humanoid robots. Yes, an American company buying humanoids from China and putting those robots inside factories where any mistake is costly. According to information reported by Security Times, TI acquired the Walker S2 model from UB Tech and is already testing the robots on production lines. Deal values were not disclosed, but the partnership doesn't seem to be just a purchase. As Texas Instruments integrates the humanoids into operations, UB Tech is committing to incorporate more TI components into the robot's core architecture. This is huge because it brings humanoids into clean rooms, environments that require extreme particle control, ultra-low vibration, and absolute precision in handling materials. Here's the contrast. UB Tech had already validated humanoids in automotive logistics with companies like BYD, Geely, and Volkswagen. but semiconductors impose far stricter constraints. What TI seems to be evaluating is the use of humanoids in specific tasks, such as handling and inspection, leveraging a real advantage of this form factor, operating in narrow aisles, dealing with machines designed for humans, and adapting to older layouts without demanding large structural overhauls. There's another strategic layer: supply chains moving back and forth. UpTech has acknowledged that even with a supply chain mostly concentrated in China, it still depended on specific compute chips. By strengthening ties with US companies, China seeks stable access to critical high-performance components. For Texas Instruments, validating its chips inside the Walker S2 puts the company at the center of the emerging industrial humanoid robotics market. And according to UpTech itself, demand for humanoids could reach 10,000 units per year in 2027. Now pause and think about the inevitable side effect. If humanoids enter the most delicate sector in industry, with maximum demands for precision and control, that changes the kind of work available. And that's where the third piece of the puzzle comes in: a job market locked up while AI grows like a steamroller. No job is safe, stagnant work, and the narrative of AI inevitability. If you know someone in the United States trying to change jobs, the frustration is familiar. Hiring is stuck. Wages are flat, freelance work is growing instead of full-time openings, and benefits keep shrinking. It's an economy that grows but doesn't hire at the same pace. At the same time, AI has never received so much investment. Trillions are flowing into data centers, chips, and bigger models. And the uncomfortable question appears: is AI tied to job stagnation, or are we being led to accept it as inevitable? While economists point out that deep impacts can take decades, big tech leaders say the revolution has already begun, and one of the most influential voices reinforcing this is Sundar Pichai, CEO of Alphabet. In a recent interview with the BBC, Pichai called AI the most profound technology humanity has ever developed and said disruptive changes are inevitable. He even said no job is completely safe, not even his. According to him, running a company like Google could become one of the easiest things for an AI to take over. The message is, change is coming, it will hurt, and everyone will have to adapt. Some roles will transform, others may stop existing for humans, and society needs to talk about it. But there's a critical point. The people leading this debate also have interests. Pichai isn't looking in from the outside. He runs one of the largest AI forces on the planet. Reinforcing the idea of inevitable automation also strengthens the narrative that justifies internal changes, cuts, restructurings, and new forms of work. In practice, what we see now isn't the complete replacement of workers, but fragmentation. Fewer formal ties, more task-based work, less stability, and wages under pressure. Without AI replacing an entire function end-to-end, at least for now. And that forces us to face reality with maturity. When Google's CEO says not even his job is safe, that isn't just a distant future. It's a sign of a present in transition. The market isn't ending. It's changing quietly. Fewer stable openings, higher tech demands, and more value for those who master AI tools. And the hard truth is this: those who don't learn to use AI in the coming years might not be fired immediately, but they will stop being considered competitive. When you put the three pieces together, the picture is clear. Simulation has accelerated physical AI. Humanoids are starting to enter the toughest industrial environments, and work is already changing, not with a jobs blackout, but with a redesign of relationships, roles, and requirements. And the question that remains is, when robots start learning before they exist and begin operating where precision is extreme, how long until this becomes standard? If you want to follow these shifts before they turn into invisible routine, subscribe to the channel and turn on notifications. And drop a comment below. Do you think humanoids will first dominate specific tasks? Or will they become general labor inside factories? See you in the next one.